All right, so let's see if we can get number 22 from 18.4 correct. Hopefully, maybe. First one, A. I want to integrate over the line from 0, 0 to 2, 4, the vector field 2x e to the y, comma, x squared e to the y. What do you note about that?
It's the gradient.
Okay, so you might note immediately, right, that I'm doing the integral over some line of a gradient of some function f dotted with dr, right? So then I can apply the
Theorem of line integrals.
fundamental theorem of line integrals, which tells me that I should get what?
X squared e to the y.
X squared e to the y, right? The thing it's the gradient of evaluated from
0, 0 to 2, 4.
0, 0 to 2, 4. Why did you do points?
Because there's two variables.
Because you have to, right? Okay, good. All right, so you get
4 e to the
4 e to the 4 minus
0.
0 gives you 4 e to the 4, which is a lovely, weird, symmetrical number, and the answer for part A. Cool. Part B. Ew.
Yeah. It's not super ew, could be more ew.
Okay, so what should I think? I just had so much luck using the fundamental theorem, right? That I would think to myself,
Try it at least.
yeah, you should spend at least 30 seconds just thinking, hey, is this the gradient of something, right? So if this was the x derivative, right, what would your f be?
It'd be x.
X squared minus yx? What, x squared over 2 minus yx? Okay, and if this was the y derivative, what would you get?
X squared plus y squared over 2. Oh, x plus y. X, y. The
Words.
Yeah.
This thing.
Blah, blah, blah.
Words are hard. And then really there's plus constants, right? So this first guess should have a constant with respect to y. This other one should have a constant with respect to x, right?
Yeah.
That could match this guy and the y squared over 2, right? And the constant with respect to x, that could be x squared over 2. But
Well, yx and xy are both functions of each other.
yeah, I've got xy and minus yx. I'm not going to be able to reconcile those. This isn't a gradient of something. So what?
Try something else, parameterize.
Yeah, try something else. Okay, so C then is given by some r of t, right?
Yeah.
What's your r for getting from 0, 0 to 2, 4 on a line?
It's gonna be 2t, 4t.
Perfect. 2t, 4t. Very nice. Okay, so what's dr then?
2 and 4.
Okay, what's the vector 2, 4? D,
dt.
t. Perfect. All right, so I need to plug it in, right? So I'm trying to integrate g from where to where?
0 to 1.
0 to 1 in the t's. Good. I need to dot with dr, so I've got a 2, 4.
You should probably make more room.
Oh, and I should probably make more room. Okay. Okay, so I've got something dotted with 2 comma 4 dt.
Yeah.
What goes in the big blank spot?
2t minus 4t, comma.
2t minus 4t, comma
2t plus 4t.
6.
And then dot this. Dot.
Okay. So I get the integral from 0 to 1 of,
-2t.
that's negative 2t, right?
Negative 4t.
So I got minus 4t plus
24.
There we go, that's where I was going.
24t dt.
Yeah.
Arithmetic error?
I dropped a minus minus sign turned into an equal sign.
Okay, so I got the integral from 0 to 1 of 20t dt gives you
10t squared. Oh, okay, yeah. That works too.
10t squared evaluated from 0 to 1, which is
10.
so there's the answer for part B. And Green's theorem does not apply,
Okay.
right? Because there's no area.
Alright.
So yeah.
Could we have taken the curl to see that it didn't equal 0?
Definitely. We could definitely take the curl. So maybe that would be a good exercise. So what's the curl of G?
The partial of x times xy.
Okay, so that's partial with respect to x of which
XY.
thing?
The second.
Yeah,
X
x
plus
plus
y.
y.
X plus y. And then I need to subtract from that the partial with respect to y of
X minus y.
x minus y. Okay, so you get
1 minus a minus 1, which
Okay.
equals 2. And that's not equal to 0.
2, which is specifically not 0, so this thing is definitely not half independent.
Is there a reason why we're doing the partial x of the y?
Yeah.
That was the part I was kind of like, now I know just the, out of repetition, but.
Yeah, so kind of why does this piece go with that one and the other?
Yeah.
Like,
which
why are
seems
they
backwards.
mismatched?
Because we want
That's
x
the-
plus y, FYI.
Yeah, really is the idea,
Determinant of
right?
2 by 2.
Is if it was a function, right? If it was the gradient of something, then fxy and fyx should be equal. Here's the partial with respect to x of the thing I'm proposing is fy,
Oh, okay.
right? And here's the partial with respect to y of the thing I'm proposing as fx. Well, if those two things aren't equal, then at the very least, this is an inconvenient function. Does that kind of make sense?
Which is why it equals 0 when.
Yeah, when it's 0, right, that
It's
means at
equal
least it's
size.
kind of a convenient thing, probably it's the gradient of something. When it's not 0, it's definitely not the gradient of something. At least not something anywhere near it.
Yeah.
Cool?